Good evening, everyone. We will get started here in just a couple of minutes. Starting with Chapter 7, Development Strategies. All right, Chapter 7, Development Strategies. Okay. So, traditional versus web-based system development. So, in Chapter 7, you're going to learn about how a systems analyst must consider in the development process which development you're going to utilize. And when you start to evaluate how or the process that you're going to use in the business evaluation, you're going to see which is going to be beneficial, best and most beneficial. So one decision you have to make is whether a traditional style or a web-centric framework will take place. And that is going to be one of the biggest decisions you're going to make as a analyst if you're going to go down that road. Two environments that are web-based development you're going to see out there are going to be the MERN stack, MERN stack, or the Microsoft.NET. Some people even refer to it as Visual Basic.NET. Still, it is owned and operated by Microsoft. The considerations for this type of traditional development are going to be compatibility issues. Traditional development may have legacy type systems that you're not going to be able to integrate with newer technology. Some of it is just going to have to be sunsetted and replaced. Some systems are designed to run on local and wide area networks. Some are not. Some systems will utilize the internet, networking, and resources of the like. So your development paths will be in-house development or purchasing software that's already created, buy it off the shelf, currently developed, or you may want to use outside consultants. Okay. Something to consider will be the scalability of the affected network. Is there limitations? Are there constraints? Is there financial constraints? Again, I refer you back to the Iron Cross that we talked about before if you're looking at a project. When you start looking at these projects and the software, you're going to have to evaluate the computing power, the desktops, laptops, and then server systems. You have to have substantial support from the technology to be able to run these. And then you also have to take into consideration the security. It is always an issue, and you need to make sure that if you're doing a web-centric build and you're having a web-based system, that your security is adequate, but it's also the proper base and level of security that is not overpowering what you actually need. There's got to be a balance of security based upon the need. If you get into the habit of putting in too much security, you substitute security for latency. So often what you will see is the more security you add to a system, the slower your network will be. You have to come up with a balance of what is necessary and what is required. So your systems will be developed and delivered on a internet-based framework, and those developments treat the web as a platform. You're also going to see how Azure or software as a service platforms are going to be very prevalent. These types of systems are scaled very easily and they grow very easily. A lot of these systems are based on C programming, the same style of programming that's utilized in your telephone, your cell phones, your laptops, your operating systems. So they're easily programmed, easily maintained from a software development standpoint. And you have to use a customer relationship management, order processing, and materials management system to be able to support these larger software systems. Essentially, you're going to be moving your organization if you're going to be the customer, or if you're going to be the consultant, you're going to be moving your customers to a EIS, or an enterprise information system, which is a fully integrated system across the entire organization. That's what we're slowly getting towards as we move through this book. So you're going to need to make sure that your customer or that your company is treating software applications as a service, and that they're less dependent on desktop computing and that power that comes from those. They cannot continue down the path of making sure that they have desktop applications that run those and siloing information. That type of platform has gone the way of the dodo. And if you are not migrating information and technology to the cloud or to the internet, then you are not going to be sustainable as an organization or thrive. Excuse me. When companies acquire web-based software as a service rather than a product they purchase, they can limit in-house involvement and have the vendor install. Okay. So what this is also saying here is, just like Microsoft has done, just like Adobe has done, you name it, what happens when you do software as a service or licensing subscriptions, you're limiting your in-house involvement, and you're putting the burden on not just the software licenses, but even your hardware. You're putting the burden of ownership of the hardware, the networking, the server systems. You're putting that off on somebody else. So you're taking a lot of the cost of servers and cloud infrastructure, network infrastructure, switches, subscription, and all you're having to do is pay a subscription or a service to those companies. They're responsible for keeping the systems up to date. Whoa, what just happened? So sorry. Okay, we're just going to move on. So I apologize about that. The PowerPoint just went crazy. So there are evolving trends. Like I said, there's cloud computing. There's Web 2.0, which now we're actually moved in. This Web 2.0 is an older model. We are into the, some call it Web 3.0. Some call it the social media network or social media internet or Web 3.0. But second generation web enabled people to collaborate, interact, and share information. There have been a few renditions of the internet over the years, but the one we're in now with cloud computing and data storage and the ability for us to be able to do what we do now is, it's very next level processing. And what has driven the research in this time is our instant gratification society. We want the data, we want our information, we want it now. Mobile devices, tablets, laptops, those have driven and are fueled, excuse me, that that network, and us increasing the speeds on our cellular network has also pushed that drive. Governments in the United States requiring communication to all homes by a certain time frame, and so over the last couple of years, there's been a big push that every home in the United States has got to have internet connectivity, and so now we're seeing those as requirements. Used to, they had to have telephone lines. Now it's actually a internet line, whether it be DSL or fiber. And so things are changing when it comes to internet connectivity. So again, in-house software development options, you can buy or develop. And when it comes down to those, it's total cost of ownership. Are you going to hire the people that you need to be able to develop in-house and maintain it, or are you going to buy the software you need that's already built and then pay the service fees for them to maintain it for you? Those are really what you're going to have to figure out. So here's a good pictorial representation for building, buying, whether it's going to be in-house or outsourcing. Okay. Now, software packages obtained from a vendor or application service provider. These are certain terms that you need to be able to be familiar with. Software vendors, these people develop software and sell it. Your value-added reseller enhances a commercial package with customer features. Horizontal application, used by many different types of organizations, and vertical applications, handles specific business requirements. So developing software in-house. So satisfies unique business requirements. It's not possible with standard commercial software. Minimizes changes in businesses' processes. Meets constraints of existing system technology, and develops internal resources. So there's a couple of different differences, but mostly it's whether you buy it or you build it, you're trying to achieve the same thing, but there's limitations doing it in-house that you're going to have to overcome. And one of those biggest is knowledge. How much are you willing to throw at it? Okay. Now, it is going to cost you less to go out and buy it. Why? You're not going to have to train people, hire them, bring them on board. There's just too many costs associated with it. Now, unless you're going to be designing specific software and no one out there makes it, or you do something so specific that you have to have software designed, then it is always cheaper to purchase. It does require less time to implement than to wait to build it, test it, and put it out. You can look and read about the proven reliability, performance, benchmarks. Anyway, you can see that it's good, or you can read about its performance, or you can see where it's not good, and you can make your decisions based upon that information. Also, on a purchased package, a lot of times you can pay to have it customized for what you need it to do, and you can negotiate directly with that company on making those enhancements. Now, when you're creating user applications as a software developer or a consultant or a company that is hiring people, you have to utilize standard business software. Okay? So you have to utilize, Visual Studio, or something along those lines, or a Microsoft database, okay, SQL, or Linux, Unix, something along those lines if you're using it to make a database. And then if you want it online, you could put it through Azure, you could go through Amazon Web Services. You're going to have to utilize standard business software, okay? And then for the user interface, you're going to make sure it enables effective interaction with that application, okay? Then you have to provide your own source support, right? Now, outsourcing. Think about it this way. Outsourcing, very simply, is sending your support or your software to another company outside the United States or inside the United States or outside of a country if you're in another country. Okay? The growth of outsourcing is continuing to grow. Some companies have brought it back into the United States. A lot of them haven't. Okay? You can look at it as application service providers delivering this type of support, or internet business services, okay, using web-based support. There's a couple of different fee models. You can do fixed fee model, subscription model, or usage model, or transactional model, okay? Each one of these is different based upon how you pay for it, for what service, right? And you can look at the definitions on this slide, okay? Some of the different services that are performed depend on what you really want them to do. If you're only concerned about keeping mission critical services, then that's what you pay for your outsourcing. If you are wanting to make sure that everything stays up and running, then that's what you pay for your outsourcing support. But if employee job security is a major concern, then you don't want to outsource. So offshoring, that's another form of global outsourcing. This is where you put it in another country, okay? IT development, IT support has gone this way before. There's a lot of risks and concerns, impact on the economy, project control, security, disparate cultures. Now, we've talked a lot about software as a service. This is cloud infrastructure. Does reduce service needs or customer needs of software maintenance, operation, and support, okay? And it does provide a lot of functionality. Now, as a systems analyst, you're able to help a company look at what their current needs are and their future needs and be able to evaluate what they can pay for and what they really need and where they need to be focused on for the future. It's a neat role to be in, but you need to be able to have a good grasp of what the business does and really be able to understand what the business is striving to do and what their mission statement is, okay? Now, analyzing cost and benefits. As a systems analyst, you need to be able to run analysis tools like payback analysis, return on investment, net present value. These will all be able to build reports that you'll need to show the CEO or the president or the board of trustees what you're going to do, how you're going to save money, or how you're going to benefit, or what you're doing is benefiting the organization, and where you're going to, make money or pay for what you're doing, and getting that return on investment, or showing the net present value of how you're earning your money back, okay? And then you're going to be able to show them off a cost benefit analysis checklist and show them all of these things in bullet points here, and justify your job and your consultant's job or your department's job and all of your developers, okay? Now, moving forward, there's going to have to be other softwares that you're going to have to acquire, okay? Or, justify what you've already acquired. You're going to have to be able to look at key features, identify what part of the network or how much of the network services or web-related items or issues that they're going to have to be addressed, estimate the volume and future growth, specify if there's going to be consumables like hardware, software, and personal constraints, and work through those. And then you're going to need to work with vendors, internet vendors, consulting firms, online forums. And then you're going to need to evaluate the alternatives, existing users, application testing, and benchmarking. Okay. And on that cost benefit analysis, you're going to have to calculate the total cost of ownership because you have to give them the reality. Okay. The study conditions of use that come along with the software license. And if the software package is purchased, consider supplemental maintenance agreements and how much that'll cost and how much that cost will grow. Will it be exponential? Will it be minuscule over the next 5 years? Okay. Then prepare a recommendation, costs, benefits, advantages, disadvantages, and make a submission in a formal system requirements document and deliver the presentation. Okay. Now, once you complete your system analysis tasks, you're going to need to complete the documentation. Pretty much everything we've talked about for the last 30 slides or so, you're going to need to make those documents official. Give them the requirements, describe the alternatives, make specific recommendations to management, and similar to a contract that identifies items system developers must deliver to users and format the organization's system document easy to read. Okay. Make a professional presentation. This slide shows suggestions for what an effective presentation would be. And depending on management's decisions, a systems analyst will do one of the following, and you can follow up on this slide. Okay. Then once you've done that, you're going to prep for transitioning to the system design. Okay. First and foremost, you're going to take that recommendation document and you're going to convert the documentation over to a design recommendation document. Okay. Provide detailed specifications for output, input, and data processing and requirements. These are going to be utilized for further defining the development or the purchasing of the software. Then you're going to need to identify the logical and physical design. Okay. All right. There is the summary slides. Ladies and gentlemen, again, if you have any questions about our Chapter 7, please feel free to reach out to me. Otherwise, I hope you'll have a wonderful week.